Elastic Security empowers security teams everywhere to prevent, detect, and respond to threats quickly through a unified solution. And it's free and open, putting you in control. Use Elastic Security to eliminate blind spots by analyzing all of your data, no matter its volume, format, or age. Stop threats at scale with automated threat and anomaly detection, and arm every analyst with fast search and integrated case management. Download or try Elastic SIEM for free and experience the benefits of an open security solution backed by world-class security research at securityweekly.com/elastic. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. Hackers attack systems that are not patched. You need protection, but virtual patching isn't working. That's why you go patchless. Topia analyzes, prioritizes, and remediates vulnerabilities before they're exploited. Even the 0 days, all from one interface. Security gets better memory defense to complement endpoint strategy while improving overall vulnerability management and compliance. Adopt a hacker's mindset, eliminate vulnerability. Get your 30-day free trial at securityweekly.com/vicarious. Welcome, everyone, to Security Weekly Virtual Hacker Summer Camp Interview Series. I'm Paul Asadorian, and I'm here with no stranger to the show and our good friend Corey Thuen, the co-founder of Gravwell. Corey, welcome.
Hey, thanks for, I'm glad to be here representing B-Sides, Idaho Falls.
There you go.
In lament of not being able to hang out in the hallways and do the beverage talks and everything like that, but we're doing it virtual.
That's it. We're virtually drinking all the booze and logging all the things, right?
Exactly.
And Corey, today we wanted to dive into, you and I had a very kind of brief discussion and like light bulbs started going off. And I'm like, yeah, there's a really big difference between a more senior person doing a threat hunt analysis and kind of study versus what's going into your SIEM and what might be operationalized across your other kind of functional IT teams. So, Corey, from your perspective, working on this product with a lot of customers and having a background specifically in, event analysis, what's the difference in those kind of subtle and not so subtle differences between that threat hunt and your operationalization of the SIEM?
Yeah, let's talk about that a little bit, because that's honestly, that was since starting Gravwell, years ago, that was one of the interesting things just for me personally. I've been in the security industry for a long time, did vulnerability research mostly on the offensive side of the house. And so when I switched over to the blue team, it was kind of interesting to see the different organizations, the resources that they've got, how they approach blue team stuff. And I had a couple assumptions that got blown up pretty early in terms of, because I was, sort of naively operating in that, you've got these security experts who are going to be at every organization, and they're going to have lots of time to spend looking at logs and finding bad guys and things, right? Which, of course, isn't the reality, because there are so many things that have to constantly get done all the time. And not every organization has the luxury of having a large security team as well. And so we've got these tools out there, and it's been interesting to watch the industry mature as we've gone from Snort dumping to Logfile or something to now we've got SIEMs, we've got all these crazy AI tools and stuff to help us out. I thought it'd be a good idea to kind of share some of that knowledge, dive into what those the difference between the platforms are, why a company is going to use one versus another, how they can help you in your organization.
Yeah, and I think,
whatever.
Back in the day too, when I think about it, it was, 20 years ago was before many organizations had SIEM. You can get a SIEM platform now for really virtually any size enterprise, right? But back in the day, it was, you were threat hunting and you kind of were the SIEM like all in one thing, right? Because you hadn't, like when I worked for university, we had embarked on the project to say, well, we're going to have this one central place for everyone's logs. That was a huge project, and that technology was still new 20 years ago. So largely, we would do threat hunting, find as much as we could from anyone who would send us logs, and then file tickets, basically, right?
Yeah.
And it's good to see that we've made this progression, and there are still two camps, and we can't lose sight of that. Like, everything shouldn't be just the threat hunting, and everything shouldn't just be the SIEM and operationalizing that, right?
Yeah, absolutely. I think that's a good point, that it's easy to maybe lose sight of or get sucked into some of the marketing around that stuff, right? Like, not fault to them, because everybody's trying to sell their software and their whiz-bang tools. But, there's a lot of tools out there that are like, and this is sort of in the SIEM side of things, where you put in, your data, like a bunch of decisions are made ahead of time for you. You put it in, and then it's going to do some crunching and give you your alerts, give you your ability to create tickets automatically, or it's kind of this pre-built, nice packaged way of just put your stuff in here and then we'll solve your security for you, especially when you start adding AI and threat feeds and some of the things that these tools are purporting to do. It can be easy to lose sight of sort of some of the fundamental blocking and tackling that still is vitally important to an organization. And nowadays we call that threat hunting aspect, that can kind of take sort of three forms, because SIEMs are great and they're really helpful for getting you up and running quickly, but they're kind of a set of rails. And once you're set on that rails, like deviating from the rails can be very difficult. If you're trying to analyze some data that that you didn't know that you needed, or that got normalized in a certain way, and so now you lost the underlying record that created that, it can be tough to sort of root cause and fully investigate a potential threat. Or
and I think it's important, Corey, too, to mention that if you have a SIEM and you've got the SOAR and you're automatically generating tickets, that's important. We need that today because we have so many systems and everything is fluid and dynamic. And there are things we can say, hey, when you find this, generate a ticket, make this blocking rule, and I think that works. And when we say automation, we're not saying we're automating everything. There's humans involved, and we know that when we find certain events, we can automate the actions around them that can basically take stuff off of our plate so that we have more time for threat hunting, right?
Absolutely, and that's the goal, because with threat hunting, it's very important that humans. There's still no better security tool than the human brain, even though we've got AI, we've got all this scalable stuff. It's humans that are so good at recognizing patterns and seeing the anomalies and knowing their own environment and having context. You can keep that all in your head, but AI and context generally don't go well together, and there's reasons for that. So there's kind of three sort of strategies or ways to go and do threat hunting. You've got kind of like you said, if you've got a SIEM, like you're going to be detecting threats, initiating some of these tickets or whatever. That's kind of the indicator or the tip based threat hunting activities, to where you've got something that is a bad, and so you're going to investigate and go about doing that. And then AI assisted, I want to put the bold underline under assisted in terms of what you might want to do. So if you've got some fancy AI built into like some user behavior analytics or something, that can indicate or act as sort of another kind of indicator that can lead you down a threat hunting path or start off some of that investigation. But sort of traditionally, threat hunting, when it originates from a person, is hypothesis driven, to where you're going to kind of create that hypothesis that says, I suspect that, or I hypothesize that our SSH is receiving abnormal amount of attacks or something. And so I hypothesize that somebody has tried to brute force or come in that way. And so then I'm going to begin a hunt where I am going to sort through and try and look at those logs and et cetera. And those are kind of the three ways of going after threat hunting. And they really do require a little bit of a different tool, because if you try and do all that stuff in a SIEM and just stay in that, you're kind of stuck on those rails. And that's where things like data lakes, additional tools where you have the data and you have the flexibility to go in through and query that data, whether it's something like Gravwell or Splunk or something that's kind of outside the direct, more SIEM style of things. That gives you that freedom to do that. Or if you're putting it in like a Hadoop cluster or doing your own sort of data science, which is certainly a buzzword, but an emerging area to where people realize, yeah, we've got all this data, we can use really interesting techniques. But then that's a little bit more difficult because you're using, like Jupyter notebooks or something to try and prove out some of these hypotheses, which is often not fast enough or not easy enough. So there's different sort of stages of how you can begin doing security and threat hunting and active analysis of your data. I think that's the key difference as well between threat hunting versus indicators and purely just going the SIEM route. Is you're going to be doing a lot more active activity within your data, which helps take advantage of that context that you've got. So that's why it's important.
Yeah, and I really, now that you say that, Corey, I like, well, of course, you're sponsor of the show and all, but I love the Gravwell tool and platform as that place where I can consolidate all that data, right? As the analyst, I may say, I want some packet captures, I want some logs, I want some sysmon, I want some of this and mix and matching it. And if I can get it all in one platform, then I can do the analysis in one place rather than having 3 or 4 or 6 different tools that I have to go manually kind of pull that data together, right?
That's really absolutely our value prop. And the single pane of glass, which has turned into a non-term. But the goal with that was being able to put everything in one spot so you can hunt it all and correlate it all at once. But that becomes very difficult when you have to make pre-decisions about the data. Does that make sense? So that's where like a data lake is an advantage versus something more strict like a traditional database or something like Elastic or even a data warehouse. In terms of, it's all about that scalable, how much pre-decision do we have about the data before we stick it in?
Right.
And that's really the limiting factor between what makes single pane of glass not work, is because a lot of people were using tools that required a lot of upfront decision about your data. And when you're talking single pane of glass, you can't. That's why a data lake where you just dump the data in, that has advantages. There. But just from a technical perspective, some of the disadvantages then are like if you're just dumping data into a lake, right, and you want to run a query that says, I'd like to count the 500 errors for Apache, right? I've got a bunch of Apache logs. I just want to count how many 500 errors there are. If you've got a data lake, you kind of have to dredge the lake to look for all Apache records that have a 500 error. Versus if you're using something like Elastic or something that has a bunch of pre-decisions about the data, then that number is just kept.
Yeah. Yeah,
right? And there are tricks that you can do, and that's one of the things that we've done at Gravwell with our data lake. Since we custom built it, we can create a hybrid approach that sort of gets the best of both worlds. But those are kind of the fundamental trade-offs between data lakes versus data warehouse traditional, or going back to traditional databases when it comes to some of that stuff. The more pre-decisions you've got lets you answer different questions easier, if that makes sense.
It sounds like
one analogy.
It sounds like you're giving the analyst the ability to have some control over the normalization, right? Whereas in all their larger systems, right, it's predetermined. That's how they're normalizing Apache logs. In Gravwell, I can say how I want to normalize those logs and correlate.
Exactly, which makes a big difference. The super high level analogy that I use sometimes is it's like having a sized wrench versus an adjustable wrench.
Yeah.
Right. The adjustable wrench is just, you can do, any size bolt, doesn't matter. Even if the bolt changes while you're turning it, you can adjust the wrench and go. But you're going to get more torque out of a size wrench because it's specifically made for that exact problem. Right.
And that's what you're doing in threat hunting, is looking for very specific conditions. And you need that level of control to uncover those conditions inside of your network. Right?
You need to be able to open and close that wrench. You need to be able to adjust one bolt over here and then immediately switch to another one when you're threat hunting, because you don't necessarily know what you're looking for, so you can't make assumptions ahead of time because you're investigating stuff, and so that's an important part. So anybody who's doing threat hunting, there's sort of 3 key things that you need as well, and maybe that's kind of where we'll close off. Is you need shitloads of data, That's sort of number one. If you don't collect your logs and you don't have them somewhere you can analyze it, then you're going to have a bad time if you try and do threat hunting. So that's sort of step number one, which is great for IR and stuff as well. You need some smart people. The people, like we've said, are tremendously important to this. You need people who know your environment, who are capable and familiar with some of those logs. Usually, threat hunters are more senior analysts, people who've seen a lot of different security incidents and stuff. And then threat intelligence is also kind of an important part to threat hunting, right? You want to know who the bad guys are, what other people are seeing. That part is important. I know you've mentioned it as, the fourth pillar of the SOC. Yep. That's the thing that you like to say. And that's kind of really ties in when you're hitting the threat hunting side of things. So, get a little bit more enrichment in terms of what it is that you're looking for.
Agreed. Yeah, and that's the correct usage of threat intelligence, right? Is to give you that enrichment to maybe send you off on a path to do a threat hunt, right?
Yeah, it can't do your job for you.
Yeah.
Don't rely on threat intelligence to do your job for you. That's
great advice. Idea. Awesome. Well, Corey, thank you so much for appearing on Security Weekly.
Yep, absolutely. Hope everybody has a good week in non-Vegas.
That's right. Folks can learn more at securityweekly.com/Gravwell. Check out the latest version. Get the community edition and or a free trial, securityweekly.com/Gravwell. Stay tuned. More interviews coming up next.
Welcome to Security Weekly's Virtual Hacker Summer Camp 2020. It's day 2. I am your host, Matt Alderman. And joining me for this segment is Deral Heiland. He is a principal security researcher at Rapid7. We're going to talk about IoT security, pen testing, some of the IoT research. Deral, welcome to Security Weekly.
Oh, thank you very much. Glad to be here.
So let me start with kind of the scope of IoT research that you've been doing, because when I hear the term IoT, you could think of commercial IoT, you can think of consumer IoT, industrial IoT. Some people even go into industrial control systems. Where is the scope of your research? Is it all, or is it a subset of those different IoT domains?
My overall responsibility is going to cover almost every one of them, and it breaks down to consumer goods, enterprise technology, industrial, transportation, and also medical. Now, I haven't necessarily personally done work on every one of those, but generally our team and my involvement involves all of those verticals.
Got it. So when you think about some of the research that you're doing, I want to start first with, how do you test some of these devices? We've used traditional pen testing techniques in traditional IT systems. Do the tools and techniques change for IoT, and do they vary by these different classes of IoT?
Yes and yes. So generally, when we're thinking about IoT, to actually test it, we want to look at the entire product's ecosystem, whatever that would actually be. For example, if you're looking at a consumer-based IoT, you're going to have cloud services, cloud APIs. You're going to have some type of embedded hardware, and often you'll have some kind of mobile application. And you can't actually test these parts individually. They got to be tested kind of together, because the security one impacts the others. Probably one of the bigger differences with this over typical pen testing is, beyond the mobile apps and the cloud APIs and those services, you have a hardware component, which involves digging all the way down to testing the physical hardware. Is the intellectual property secure in these devices? Are there known vulnerabilities? What kind of attacks will work against the hardware? Can I extract data off this? If somebody buys a device, uses it, and destroys it or gets rid of it, can somebody go in and pull that data off, even if it's factory reset? Just a whole lot of different things that are related to the hardware that's different than typical pen testing.
Right. And so, like in the Rapid7 portfolio, for example, if I'm going to go test the cloud or the web app, you've got the AppSpider product, right? You have different components there. But when you get to the hardware level, I mean, how do you test aspects of like the firmware and vulnerabilities there? Does Nexpose help you there, or are there additional tools you have to bring into the portfolio to test things at the hardware level that maybe you can't use traditional tools for?
Yeah, from the traditional tool standpoint, obviously from the embedded hardware, you can run scanners against it, Nmap against it, some of the vulnerability scanners that may detect things related to it. But when you go to the next level and you want to actually go into the device, you're going to need everything from debuggers, tools for doing JTAGs, soldering equipment to go into it. And then once if you do extract the firmware, then it's throwing it up in IDA or running strings against it. You're looking for embedded passwords, hard-coded keys, anything that would allow an attacker to extract data from one device and attack the entire product line.
Right. Yeah, new tools. I know Paul has more experience with some of those tools than I do because he's done a bunch with embedded systems. Now, when we think about kind of results from a lot of your research, do you see a lot of differences based on the different types of classes of IoT, or are there similarities in issues that kind of transcend all of them? What's the same and what's different?
I think in general you can have the same type of issues. The default passwords, the hard encoded stuff, devices, technology that interact with machine to machine over cloud APIs. Those same type of vulnerabilities and risk and threats associated with that. One of the big differences is often impact. Something I find on some standard consumer good may be a risk for privacy, but when you start getting into medical or transportation type stuff, the risk goes up exponentially, potentially endangering life. That has to be considered.
Yeah, and I think that's where when I look at things like industrial IoT or industrial control systems, the potential impact of a vulnerability in those systems have greater impact because they could cause safety issues or loss of life type of issues. So what are some of the things I mean, we know default passwords on these devices is a common one, but what are some of the other big things that people need to be looking for on these devices?
Typically the stuff that I like to look for is how the ecosystems communicate with each other. So when you start looking at the hardware, you can easily start looking at what kind of calls it's making out. Can you identify those? How is that machine-to-machine security, and how someone can gather that information off this device and use that for attacking other devices? That's just kind of one example that we typically look at.
Yeah, so that would be kind of the authentication mechanisms between the hardware in either the mobile or the cloud service, which is typically probably done through an API or something along those lines?
Correct. Yeah, typically from an API. Most of the time we're all familiar with testing the human to machine aspect of stuff and the security about that. And often vendors or producers really think about that is like, hey, if it's a human entering, you don't know what he can enter. So you got to take all these risks into consideration. But then a lot of times when they start thinking about back end, it is like machine to machine, things like MQTT, things like this that take place in the background that they often don't think about the level of attacker intervention. And it's common to see those things not have the level of security that you would expect.
Yeah. Yesterday we did a segment on satellite broadband. And when you think about industrial IoT, like in an airplane or on a ship or something like that, sometimes the communication is through satellite. Does your research look at some of those connections outside and how they're connecting to these services through these other transport mechanisms than maybe a traditional internet, for example?
Yes. Obviously, when you get into some of these communications, we have to be concerned with FCC regulations and stuff like that, and it's kind of limited in what you can do. But often we take that into consideration. I want to see what's going on in reference to those other communications, whether it's 3G, 4G, 5G, or whether it's going out some other mechanism or some unroutable RF protocols. So what we can't capture and analyze legally, we'll often get into examining from a more of an interchip communication. So often communication going out through these things come from main processors, and you can interact at that level there and work on decoding that. And often you can avoid some of the encryption if that data is flowing between microprocessors on the board.
Right. Yeah, because one of the big challenges with some of the satellite communications we were talking about yesterday was the encryption component and how some of that stuff can be intercepted and clear through the satellite communication. So interesting. Now, are you doing IoT Village this year for DEF CON as well?
Me and a couple guys at Rapid7 are actually going to be running a few kind of learning exercises. We kind of miss out on doing that hands-on thing that we've done in the past, but this year we decided to turn it into some learning sessions. So we'll be doing one on building a IoT hacking lab, which I'll be going over like tons of equipment like I have purchased here, showing it and discussing it in general. We'll be doing one on using a logic analyzer, some basics on that, and familiarize people with some of the functions around that, because it's a cool piece of equipment and vital to have into your lab. We'll also be talking about some U-boot stuff, some simple attacks for getting into U-boot and using that to compromise a host. And then I'm also going to be talking about extracting data or file systems from NAND flash chips and pulling that data out and rebuilding it.
Got it. So everything will be virtual, obviously, this year. So a lot more kind of learning sessions than what you've traditionally done, which is more hands-on in IoT Village, right?
Yeah, exactly. During the exercises, we've tried to kind of fragment the exercises up into kind of learning objectives, and then stopping after each learning objectives, and hopefully we'll have a Q&A session so people can ask questions, and instead of having to wait clear to the end and then you forget your question, we wanted it more of a learning opportunity versus just a information dump opportunity.
Right, yeah. Now, I know Rapid7 just released the NICER report. We're actually going to do a webcast with you later this month with Todd Beardsley. Is there any new kind of research that people should be looking for on the IoT stuff that Rapid7 has published lately?
The only thing that I've put out from an IoT standpoint is kind of our methodology around looking at IoT assessments. Do expect over the next couple quarters some interesting stuff coming out. I've been working on forming some partnerships with various organizations or businesses and looking at deployed technology with the goal to come out with a paper where we discuss looking at an IoT implementation, everything from acquisition, deployment, the technology, to ongoing maintenance and management of an IoT-based environment in an enterprise. So working on that right now, and hopefully have a white paper out early in Q4 on that. Now,
are there specific defense mechanisms? Will that be included in that? Because as you think about the testing side, we can identify some of these vulnerabilities. You get into the defense side as well, and some of this research on what are some of the ways to defend these environments better?
Yeah, the goal with that particular research project is to discuss those best practices. How do we think about acquisition and security during the acquisition process? How do we think about mitigation, things like that during deployment, patch management, all that type of stuff? What if there is known vulnerabilities? How do we approach it? How do we protect our environment? Those type of things. So I'm hoping to cover all of that in that white paper also.
Well, that'll be great, because I think that's where people struggle the most is how do I think about defending these environments and these systems, because they are different. I mean, the components that are in them are different, and we can't necessarily apply traditional security defenses to these environments. So any guidance there, I think, will help people, because I think that's one of the major challenges.
Yeah, I agree 100%.
Yeah. And I assume all the research will get published to rapid7.com/research. That's where most of your stuff goes, right?
Yes, it will.
Okay. Perfect. Deral, thank you so much for giving us an overview on IoT security.
Thank you very much for having me. It's been great.
Yes. And if anybody wants to learn more about Rapid7, please visit securityweekly.com/Rapid7. And with that, stay tuned. We'll have more interviews coming soon.